True Projects. In this video, we are going to explain about the project, which is active learning based on transfer learning techniques for text classification. Introduction of the project. The project addresses the widespread use of machine learning techniques, particularly in text categorization, where challenges persist due to the need for large label datasets. Despite advancements in automatic labeling, manual labeling remains crucial in various domains, making data annotation a challenging, expensive, and time consuming task. Primary goal is to enhance the efficiency of text categorization by optimizing resource utilization. The project explores the use of automatic and semi-automatic annotation services to aid in the annotation process for text classification tasks. Additionally, the focus is on leveraging active learning and transfer learning to build accurate models with the reduced training data in the face of data sparsity. The project employs a combination of active learning and transfer learning techniques to address the data sparsity in text classification tasks. It involves selecting learning algorithms to demonstrate improved performance in scenarios with limited data. Building upon prior work presented in the European Symposium on Artificial Neural Networks, the project extends its scope to text classification tasks. Notably, the project includes experiments on multiple datasets from diverse fields evaluating classification algorithms using various metrics. The project also compares proposed strategies using deep learning algorithms, demonstrating their effectiveness despite the typically higher data requirements. Objective of the project. The primary objective of the project is to develop models for text categorization that use resources as efficiently as possible. This involves exploring strategies to expedite the learning process while minimizing the need for extensive hand labeling of text datasets. The project aims to enhance the speed of learning in text categorization tasks by leveraging active learning and transfer learning techniques. The focus is on achieving effective model for training with substantially fewer labeled examples. The specific objective is to investigate and implement a combination of active learning and transfer learning methodologies. Both these approaches have demonstrated efficiency and effectiveness in training accurate models with reduced amount of training data. The project's final objective is to perform an experimental evaluation on the four datasets from different domains. By conducting rigorous experiments, the aim is to validate and demonstrate that the combination of active and transfer learning outperforms random selection, leading to improved text categorization with fewer labeled examples. To implement this project, we need software and hardware requirements. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. And the hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement the project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary libraries and packages that are required for the project. We imported Pandas for data manipulation, NLTK for natural language processing, scikit-learn for machine learning algorithms, NumPy for numerical operations, Matplotlib and Seaborn for data visualization, TensorFlow and Keras for deep learning. Coming to exploring the dataset, here the project involves working with the four different datasets, which are IMDb dataset, Spam dataset, Amazon review dataset, and movie review dataset. Exploring the datasets include loading the data, checking for missing values, understanding the structure, and gaining insights into the data. Coming to the next step, visualization. Visualization is performed to better understand the characteristics of the datasets. This includes plotting histograms, word clouds, and any other relevant visualizations to identify patterns or the trends in the data. Coming to data processing, this step involves cleaning and preparing the data for model training. Here, tasks include removing the URL and other characters. Here, elimination of the URLs and unwanted characters in the text data to ensure that the analysis focuses on relevant textual content. We have removed punctuations, which is stripping away punctuation marks to simplify the text and reduce noise. We also removed stop words, elimination of the common words which are stop words that may not contribute significant meaning to the analysis. We also normalize the data to standardized form. Coming to tokenization, here we have used Count Vectorizer. Tokenization involves breaking down text into individual words or tokens. The project uses techniques like Count vectorizer to convert the text into numerical features which are suitable for machine learning models. Count vectorizer is a text pre-processing technique that converts a collection of text documents into a numerical format by counting the occurrence of each word, creating a matrix of token counts used as input for machine learning models. It represents the frequency of words in a document, producing a sparse matrix for efficient storage and processing. Coming to BERT tokenizer, BERT tokenizes the input text into smaller units, typically words or subwords. Unlike traditional tokenization, BERT uses word piece tokenization, allowing it to represent subwords and capture the meaning of words more effectively. BERT converts each token into high dimensional vectors known as word embeddings. These embeddings capture the semantic meaning and the context of words in a more nuanced way compared to traditional embeddings. BERT utilizes a multi-head self-attention mechanism to weigh the importance of different words in a sentence concerning with each other. This enables BERT to consider the entire context of a word by looking at all other words in the sentence bidirectionally. Coming to feature selection, here we select relevant features which are crucial for building the effective model. This step involves choosing which aspect of the data will be used as input features for training the machine learning models. Coming to splitting the data into train and test. The dataset is split into training and testing sets. The training set is used to train the machine learning models, while the testing set is reserved for evaluating their performance. Building the model. Multiple machine learning algorithms are employed to build classification models. Coming to training the model, here the machine learning models are trained using the training dataset. The algorithms learn patterns and relationships in the data to make predictions. Flask framework with SQLite for sign up and sign in. Flask is integrated with an SQLite database to handle user authentication, allowing users to sign up and sign in. User gives input. Here, users provide input in the form of text data that require classification. Pre-processing for prediction. The input data provided by the user goes through the same pre-processing steps as the training data, ensuring consistency and the compatibility with the trained models. Trained model is used for prediction. The pre-processed input is then fed into the previously trained machine learning models for prediction. The model provides classification or the sentiment analysis based on the nature of the project. Applying LDA model for topic modeling. Here, latent dirichlet allocation is applied for topic modeling. This step helps in identifying the underlying topics present in the input text data. The last step is final outcome is displayed through frontend. The final outcomes, including predictions from the machine learning models and the results from the LDA model, are displayed on the front end of the web application for users to view and interact with the user. Now we will know what are the algorithms used in the project. The first algorithm is logistic regression. It is a statistical model used for binary classification. It predicts the probability of an instance belonging to a particular class and applies a logistic function to transform the output into a range between 0 and 1. It is commonly used for binary classification tasks, making it suitable for scenarios where the goal is to categorize text data into two classes such as spam versus non-spam, positive versus negative sentiment. Coming to support vector machine, which is SVM, it is powerful supervised machine learning algorithm used for classification and regression tasks. It works by finding a hyperplane in a high dimensional space that separates data points into different classes while maximizing the margin between classes. SVM is effective for text categorization as it can handle high dimensional data well and it is capable of creating a clear boundary between different text categories. Coming to random forest, it is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of classes, which is classification, or the mean of prediction, which is regression of the individual trees. Random forest is chosen for its ability to handle high dimensional data, reduce overfitting, and provide robust predictions, making it suitable for text classification tasks with diverse features. Coming to decision tree, it is a tree-like model where each node represents a feature, each branch represents a decision based on that feature, and each leaf node represents the outcome or the classification label. Trees are interpretable and effective for text classification tasks. They are employed to capture decision-making patterns in the data, aiding in the categorization of text-based specific features. The next algorithm is naive Bayes. It is a probabilistic algorithm based on Bayes' theorem. It assumes that features are conditionally independent given the class, leading to a naive assumption. Naive Bayes is particularly effective for text classification tasks due to its simplicity. speed, and suitability for high dimensional data, and it is often used for spam filtering and sentiment analysis. Coming to the next algorithm, which is MLP classifier. MLP is multi-layer perceptron. It is a type of artificial neural network categorized by multiple layers of interconnected nodes, which are neurons. It can learn complex relationships in the data through the forward and backward propagation. MLP classifier, which is a type of neural network, is chosen for its ability to capture intricate patterns in the text data, enabling the model to learn and generalize well for various text categorization tasks. The last algorithm is KNN, which is K nearest neighbor. KNN is a non-parametric and instance-based learning algorithm. It classifies new instances based on the majority class of their K nearest neighbors in the feature space. It is selected for its simplicity and effectiveness in handling text data. It is particularly useful when the decision boundaries are not linear and when the text categorization requires considering the similarity of instances in the feature space. As an extension, we applied an ensemble method that combines the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built the front end using Flash framework for user testing with the user authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics, to evaluate all the classification models built in the project. So here we have performance comparison graph for the Amazon dataset, and we built all the models for all the 4 datasets. So here we have comparison graphs for Amazon dataset. This is accuracy comparison graph where x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. Similar to accuracy, precision graph also represents x-axis precision score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other graphs also. Coming to precision, it is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is the recall comparison graph. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. FN score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. Here we have performance comparison graphs for IMDb dataset. Here we have for movie review dataset and for SMS dataset. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. These are the dataset folders in which we have the dataset. We use all those datasets for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information, and those will be loaded into the project code during runtime. These are the IPYNB files. These are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign-up file. This file is the database file used to store the user information. And this is the topic modeling Python file. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Here, using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. Here we can observe that current directory is changed to the code folder's path. And now we will type the command python space app.py to compile the app.py file. And now we need to click on enter. And this command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is built by using the Flask framework. Here we can see a sign up link. First, we need to click on that and enter all the sign up details if you are signing up newly. I have already signed up and I have an account in it, so I can directly sign in. So I'm clicking on sign in now. And here we need to enter our credentials, which are the username and the password. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. As we already informed you that we will be doing prediction for all the 4 datasets. So first we'll do for SMS spam dataset. For that, under prediction, click on SMS spam. Here we can see a text box wherein we need to give the input message. Based on the given input message, we will get the prediction. So here I'm entering the message. Now we need to click on predict. Here we got the prediction that the SMS type is ham, which means it is not spam. Here the application has predicted this particular message as not spam and the topic for the paragraph is most dependent upon these words. Now we will give the other message. For that, under prediction, click on SMS spam again. I have entered the message. Now click on predict. So here, based on the given input message, we got the prediction as the SMS type is spam and the topic for the paragraph is most dependent upon these words. Now we will do the prediction for the other dataset, which is IMDb dataset. So click on IMDb dataset under prediction. Similar to SMS prediction, we have text box here wherein we need to give the input message. So here we will enter the message. I have entered the message here. Now click on predict. Here, based on the given input message, we got the prediction as the review type is positive and the topic for the paragraph is most dependent upon these words. Now we will give the other message. So click on prediction and click on IMDb. I have given the message. Click on predict. Here we got the prediction as the review type is negative, which means this particular message belongs to the negative sentiment. And the topic for the paragraph is most dependent upon these words. Now we will do the prediction for the other dataset, which is Amazon dataset. For that, under prediction, click on Amazon. So here we need to enter the message in the text box. I have entered the message here. Now click on predict. Here, based on the given message, we got the prediction as the review type is neutral and the topic for the paragraph is most dependent upon these words. Now we will try giving the other message. So under prediction, click on Amazon. I entered the message here. Now click on predict. Here, based on the given message, we got the prediction as the review type is positive and the topic for the paragraph is most dependent upon these words. Now we will give the other message. So click on Amazon again. I have given the message here. Click on predict. So here, based on the given message, we got the prediction as the review type is negative and the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, if we enter messages to the system, then the system will categorize which type of text it is. Conclusion of the project. The project successfully addressed the challenge of efficient resource utilization in the text categorization by incorporating active learning and transfer learning strategies. This optimization is crucial in handling large data sets and minimizing the need for extensive manual labeling. Through comprehensive experimental evaluations on diverse datasets, the project demonstrated that combination of active and transfer learning outperformed random selection methods. The proposed criteria, particularly the active transfer criterion, showed superior performance in scenarios with limited label data. The project showcased the adaptability of various machine learning algorithms, including logistic regression, support vector machine, random forest, decision tree naive Bayes MLP classifier, KNN, BERT. This versatility allowed the models to effectively categorize text across different domains, stars. The project benefits researchers, industry professionals, developers, and businesses by offering insights into efficient text categorization using active and transfer learning strategies. Its findings and methodologies can enhance machine learning applications, streamlining operations, and improve user experience in industries relying on accurate text classification. The project's contributions include an extended evaluation on multiple datasets, examination of various metrics for algorithm selection, and the introduction of active transfer criterion. Future research directions may explore enhancements to the proposed methodology, further advancements the field of text categorization through efficient use of resources and innovative learning strategies.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.